In today's video, it's about the Scalar module of the grid in Bitwig Studio, and I want to explain what you can do with it, what it is, what you can change with it, and how it works basically. So everything you need to know about the Scalar, and of course some tricks with it. So let's start the video. Okay, you can find the Scalar under the face category here, and it's the 5th entry. You can track this in. As you can see, the default setting is 2:1 as a ratio, which is not that when you use an input signal and measure the output, it's not unchanged, or the signal isn't left unchanged. You have to put it at 1:1, so now what comes in comes out at the end. And we can measure this by using a phase in and using an oscilloscope here to just test this. Switch to slow. Now you can see we have just a regular phase signal slowly ramping up and then going back to 0 and ramping up again. So these signals are usually used inside the grid for synchronizing devices. So you can do a lot of stuff with the Scalar, not only to phase signals, to all kinds of signals. But I want to start with the phase signal first, because that's what it's made for. And that's also why we have pink input checks, basically. So let's compare these two by using maybe just an attenuate to get here a different color in the oscilloscope. It's not to change the signal at all. I just want to use this to have a red color here. And then we take the original signal here and use it in the second input check just to compare the signals. So now you can see it's the same signal. They are completely overlapping. So now we can change here with the rate, the speed or the playback speed or the frequency of the ramp. So maybe go here to 2. So 2, I think, means just having twice the speed. So having dialed in here 2 means it's twice as fast, and 0.33 is roughly 1/3 of the speed. So you can speed up or slow down the synchronizing signal. That's what it basically does. And you have also here a ratio, which means if you dial in 2 here, you have twice the speed. As you can see, the red signal now is much faster than the pink one. And if you pull this down and make 1 to 2, then you have much flatter ramp. So it's half time, basically half the speed of the original signal. And you can use this for all kinds of things. So for instance, if you have a gates module which takes a pink signal, which is a phase signal, as an input, and it already gets a phase signal. You can see this here with the pre-chord, the phase pre-chord knob. And if you disable this, you can see it completely stops playing. So it needs a phase signal to synchronize. So we can use here the output of the phase in. And the phase in basically takes the information or generates a phase signal synchronized to your transport. So we have 65 ppm and 1 cycle of this ramp means 1 bar roughly. And you can see now it starts playing again here. And when this one is finished at the end, it starts back from the first again. So what this means is the phase signal synchronizes the gates module to the transport. So when the signal is at 0, we are at the start of the gates module, and when we are at +1, we are at the end here of the gates module. So it synchronizes. So when we put a scalar in between here, like this, we now can change the speed, the playback speed of this. So we can make this twice as fast, or 3 times as fast, or 4 times as fast. And when we use here the gates module again and use the original signal, you can see this one plays 4 times as fast as this one. Okay. So you can divide or multiply or divide the phase signal into ratios and change the playback speed of devices that uses phase signal as input signal or as a synchronization signal. Pretty easy, actually. So, but there's a problem now. The problem is that these signals are restarting at different times. As you can see here, when this one is at the first step, this is not at the first step. It's somewhere in between. And if we change here the speed and go back to 1, then it's even more out of touch. And we can also see this by comparing these signals. Just using here again the original signal and this one. And then we change here the speed a bit and go back to 1. So it's everywhere in between. It's still 4 times the speed, but the starting point is somewhere else. It's somewhere, always somewhere else. If you basically here go back to a higher speed and go back to 1, it's again somewhere else. So we need something to start at the same point, or at the start of a beat or of a bar, or yeah, basically retrigger it. And we can do this by not by using the gate input here. We have to use another module, and it's called, I think, retrigger or reset, this one here. And this also takes an input as a phase signal as an input and gives us a phase signal as an output. So go back into this, and we have also a pre-chord, which is a gate. Yeah, a gate pre-chord. So when we have a MIDI keyboard at our hands, or a piano roll, a note on the piano roll, then this one is retriggered every time we press a key or press a note or play a note. We can disable this here and use maybe a button or a trigger to reset the phase, basically. So let's try this. Go with the phase in the top one and use this one here. Okay. Now you can see we can retrigger the phase. So there's also an input here to reset, or the reset logic of the Scalar module here. Reset in triggers resets the process, but it doesn't re-trigger the phase at all. So when we use this instead of this, we can see here when we re-trigger the Scalar itself, it doesn't re-trigger the phase at all. As you can see here, it's still, as you can see, we basically iterate here at the line of this original phase. So we don't reset the phase itself, we reset the process. That also was what the description says. So this is basically something different than this, okay? On the Scalar itself, there's also here a gate output, and we can use this to all kinds of with all kinds of modules to synchronize stuff or trigger certain devices. So when we look at this here in the graph itself, you can see that, maybe make this a bit slower here. For the first half of the ramp, so starting here at 0 to 0.5, we have a gate signal happening, basically a 1 output, and for the rest of the ramp from 0.5 to 1, we have no or 0 output at this gate. So we can use this to, for instance, trigger here an AD. Maybe make this a bit faster again, 4 times. So every time basically the ramp resets to 0, we have a trigger signal, which is kind of different to using an AD and using the phase signal itself to trigger this AD, which is exactly the opposite. This AD only triggers when the signal is 1 or greater than 0.5. So basically this AD triggers when the signal is greater than 0.5, which is the second half of the ramp. And this one triggers when the gate signal is 1, which is output by the scalar when the phase signal is smaller than 0.5. So you can also use this to trigger this basically in alteration or alternation. So you can first trigger this and then trigger this just with one phase cycle. So this is the basic concept of the scalar, what it's meant for and how we can use it, basically to change the frequency of phase signals. But there's a lot of stuff you can also do with it that's not what it's meant for. And that's the great thing about modularity and modular stuff in general, or the grid of Bitwig Studio, that you can misuse a lot of modules for different stuff. So maybe we remove all of this here. I just let the scalar on this and maybe explain some simple concepts how you can use the scalar. For instance, if you have a sine and you have an AD and a mixer, and of course an audio output here. And then you have two of these oscillators, combine these, and you want to play these at different speeds, okay? And that's where the scalar comes in. So use a phase input here because we want to synchronize our complete thing here to the transport. And yeah, let's trigger here this one. And maybe use the second one and trigger the second one. And maybe use here a gate in, or yeah, let's use a gate in. So every time we press a key on the keyboard, we want to reset the process of the scalar here. So this is basically something you can do. It's pretty simple, and you can use the scalar in this case to create polymeters or different speeds for triggering an oscillator or sound source with an envelope. Another option would be to don't trigger the ADs here directly with the scalar. Maybe go for gates in between the ADs and the scalar by just, yeah, using gate modules. You can see they play at different speeds, and so this is also something that's possible. Now we basically use here the scalars to change the speed of the phase signal, and the phase signal then synchronizes the gates module in different speeds. As you can see, they play all at different speeds. And then to trigger with these, the ADs, benefit of this is that you can change the patterns of these gate modules, which allows more customization of when something is triggered. So you can also misuse the scalar for audio signals. So we have here a sine oscillator playing its sound, and we now use here an oscilloscope so we can compare these signals. So this is our sine shape here, sine wave, which is nice. And then we use a scalar, go with the audio signal into the phase input here, and then into the oscilloscope. So the first change you can see here is, the first difference is that we have a unipolar signal in the range of 0 to +1. So we have to convert the signal into the bipolar range. So let's go to B here and unit to B conversion. And now we have the full range of -1 to +1. So we can use this output as an audio signal. And this is how it sounds at the moment. So a bit like an FM modulated sine wave. So maybe go down here with the rate. You can see how the signal changes here. So this is probably our original signal, just a bit quieter. And when we go further, it looks like a folding process. So the sine is folding itself. Okay. It's almost like a wave shaper. So when we use a wave shaper here, maybe. Okay, let's call a wave shaper. And we dial this in. You can see the folding process looks almost the same. Which is pretty interesting. So you can misuse the scalar also as a wave folder. Okay, another interesting idea could be to use the transport speed, which is 65 ppm, or maybe go higher here to 120 ppm, which is kind of a frequency. So we can use the phase in here, use the scalar, and multiply this phase signal multiple times, maybe go to 60 or something like this, to get a high frequency out of it. And use this to drive a lookup module, which gets us a sound. Maybe use an AD here. And then, of course, an out. Maybe 60, and then we use here rate 16 times. So this is basically a sound or an audible frequency, which is based on our frequency of the track. So when we change the frequency of the track, also the sound or the note changes. So you can use this to base your sound or your fundamental note of your chord progression on the BPM on your track, just by using multiply number or frequency of your initial BPM of the project. This could be something that's interesting. Maybe you also modulate here the speed over the in your arrangement over time. Then this could be pretty interesting. So you can base everything on this fundamental. You can create chords from it and so on. So this is also something you can do with the scalar. So there's also a small trick where you can use the scalar for modulating other knobs or parameters. So for instance, you have a lot of volume knobs, just for an example. And you have one value knob, which is your macro on the device itself. We modulate just this. And you want to change a lot of different values. So this is where the scalar becomes handy. So go in here into the scalar. Then we need a modulator out. And then we use multiple of these. And go in here. And then we modulate all these knobs here. Maybe go for 1, 1, 1. Okay. So now when we turn the knob here and change different settings for the rate, you can kind of get some deterministic. Someone told me that it's called deterministic because every time we are in the same position here on the value knob, we get the same outcome with all the states of the gain knob here. Because these modulations are faster because I dialed in at the rate of 20. You can see it's much faster just with one turn of this knob. Get multiple iterations of this knob here. So you can have just one knob and change a lot of different parameters inside your synth or your patch. But every time you return to one position, it's exactly the same combination of modulations to all these knobs. So you get always the same combination of values here with these knobs at the same position, maybe at 50%. So you can use this to, control multiple parameters, get a lot of modulation out of it, also a lot of morphing between different states, and you are also deterministic by having the same combination of states with the same position of your initial value. I know it sounds complicated, but if you try it out or ask in the comments, then maybe we can go deeper into this. But I also made a video about this with the Chebyshev modules. I put a link in the description about these two. This was a pretty long video just about the scalar, and I tried to cover everything, including some examples what you can do with it. So we know how the scalar works, what it does, and for what you can use it. Okay, so thanks for watching this video. If you have some questions, then please leave it in the comments. I don't know everything, but I try to cover as much as possible on this channel about everything related to Bitwig. So ask me questions in the comments and I try to answer them. Please, if you like the video, subscribe to the channel and maybe think about the Patreon subscription because it helps me a lot. Thanks for watching this video and I'll see you in the next one. Bye.